Going to model basketball throws with Logger Pro, and this is the student sheet, student modeling basketball throws with Logger Pro. And the first thing you need to have is Logger Pro, the bit of software, downloaded onto your laptop. And we have this already in science in grade 9. One of the science experiments is to drop a ball and measure the time against the height, and you would do that with Logger Pro at some stage during the year. So if we go and open the Logger Pro folder from the science department, you will need to install Logger Pro, but also that's the basic package. You definitely need to install the update 3.16, otherwise the insert movie features won't work. So once you've installed these two bits of software, the Logger Pro itself, the system, and then the updated version here, all the little package updates, then you're ready to start. So I'll keep this Word document visible, but I have a printout by my hand, so I can refer to that. Down here it says, firstly open this movie. So you're going to open the movie, and you're going to need to download this also to your desktop, because we are going to analyze this movie inside Logger Pro. So it's important that we actually have this movie downloaded. It doesn't seem to be wanting to open. Things seem to be running quite slowly. Okay, I'll check on that link later to make sure that the link does work. But once you have that movie, I've actually already got it downloaded here. If I show you what it looks like, if I go to my downloads, I've got it here. And your teacher may have already played this for you. But basically there are 3 shots, 3 attempts at a basket on this video. Here's the first attempt here. You can see the shots cut away mid-throw. And we're going to try and model this using Logger Pro and predict if the shot goes in the basket or not. Okay, so I've already downloaded this, and you'll be able to download it from the link that's in the document. And so we just read through our Word document, insert movie to Logger Pro. So let's go ahead and open Logger Pro, insert the movie, and then just follow on with this little helpful guide. So let me downsize that. I've got Logger Pro all ready to go here. I will make it big size. And now on the top toolbar, insert movie. And then you're going to be able to find it. Now I've got to go through a long way here. I'm sure you'll be able to get there a lot quicker than me. But on my hard drive, on my users, I'm Ken Stirratt, and in the download section here, there is the Quadratics movie open. Okay, and there it is. Okay, so we can just make that a little bit smaller here. So you've essentially got 2 windows. You've got this video window here, and you've got a XY data set on the left here. And you've got a little graph ready to plot any data that you decide that you want to plot behind it. We're going to be working really in this window with the video to start with. All right. Now, if I go back to my my help sheet, one of the first things I need to do is open up the options sidebar, and we do that by clicking in the bottom right-hand corner. There's some little dots with an arrow, and if we click on that, you see this magical side toolbar on the right drops down open, and then we're going to use this toolbar here to help us with the analysis. So I'm on page 2 now. So what we want to do actually is I'm going to go back using the bottom left arrows. I'm going to go back. Oh, does it let me go back? I will try and go back on my movie. Oh, the movie is right back to the beginning. So I am just going to move forward a little bit in the movie. So I'm clicking the right arrow button here, and you can see the bottom left. The video is moving forward. It doesn't look like it's moving forward, but it is. It's just moving forward very slowly. I can press the play button, and you can see what's happening there. So I'm going to get to here. I've stopped, but now I'm just going to go forward slowly until I see the basketball player. And look, I'm using the fast forward frame on the bottom left of the movie. And I'm just going to keep going until just about ready to release here. So I'm in a good place now. I can go and set my axes. So the first thing is click here to set the origin. So this 1, 2, 3, the third square down, if I click, There's a big plus there. But I'm going to put the origin right on the free throw line where the feet are. And can you see it shoots up a yellow line for the y-axis and a yellow line horizontally for the x-axis. Now the x-axis is going to be the horizontal distance of the ball, and the y-axis is going to be the height of the ball above the ground. Okay, so we've done that. Now we need to tell Logger Pro what kind of scale we're using. The best thing is to measure something on the picture that we know the length of or the height of. And my friend here, Rich, he's actually 1.9 meters tall. So the next little icon down, it's hard to see, but it's actually a ruler. So if you click on the 1, 2, 3, the fourth square down, it will open up a ruler, a measuring thing. And if I click on the top of Richard's head, and then just, let me just go back, I've lost it, click. Now I need to click and drag down. So I've got to click and then drag down. Can you see there's a green line appeared now? If I go all the way to the bottom, this little scale pops up. Now I know the height of the person is I'll just check my sheet again, 1.9 meters tall. It's quite a tall guy, all right? So I need to set this now as 1.9 meters. So I tell Logger Pro that 1.9 is the length of the green line. Oh, I need to put a decimal point because it's not on German settings. And the units is meters, and that's okay. Now anything I do from here when I'm tracking out the path of the ball, everything will be measured in meters, which will be great. Now, everything's set to go. I'm going to track the motion of this ball, and you can see it's going to go up here, and it's going to form a parabola, studying quadratics, so this is a parabola. And we don't see where the basket is, it's kind of out of shot. But the idea is we're going to try and find the best quadratic model, and then we're going to use the model to predict if the ball goes in the basket. So we're going to need to know where the basket is in terms of the distance across and up, but we'll see that a little bit later. Back to the sheet now. It says once you're ready to start tracking the ball, just press your little arrows to the right until you can see. So I can see the release is just there, right? So that's probably... This is not a good place to start tracking the ball, because think about the motion of the ball. The ball's going to go backwards and then down and then it's going to go up. I think I'm ready to start tracking the ball from this launch point here. Okay? So once you're ready to start tracking the ball and you've got it just about leaving my friend's hand, and it's going to go up and curve, hopefully in a parabola, we're ready to start tracking the ball. Now this is where the super clever technology kicks in, because the second little square down is the trackpad. So as soon as you click on this trackpad, and then again it's a big sort of plus on the screen, you go and try and find the exact centre of the ball. Now you're not going to get exactly in the centre, that the ball doesn't look that circular because it's a bit blurred. But as soon as I think I've got the centre of the ball, when I click, can you see it just moves on one little time frame? So go and click on the centre of the ball again, and it moves on one time frame. So this is tracking. We're tracking the actual path of the ball, and we're going time frame by time frame. And what's happening on the left, all this data is being transferred into your spreadsheet on the left, and points are automatically being plotted underneath on the graph, all right? But we're going to keep concentrating on the video here. Keep clicking on the center of the ball, center of the ball, center of the ball, center, center. You can already see the beautiful parabola, right? You can see the curve. Okay, and it looks like that's me finished then. So I've got as many points plotted as I possibly can from the first shot. Now, I'm on page 3 at the top. It says just move the movie window out of the way. All right, so we're just going to grab this and we're just going to move it out of the way. If you go to the top left-hand corner, you can downsize it and make it smaller. That's good. All right, now it looks great, right? We've got all this data over here. And we seem to have 2 graphs plotted. Well, that's a bit weird because we only want 1 graph. Let's have a little think of what we're doing. If we go to the bottom of the graph, this is time in seconds. So the variable plotted on the x-axis is time. Now I don't think we really want time, right? We want the horizontal distance from release point. So I'm going to click on time, and it offers you all of these different options to plot on the x-axis, and I'm just going to go ahead and have x. Yeah, if you look on the far left, x is in meters. This is the distance that the ball is horizontally from the starting point. And then on the y-axis, of course, I'm just going to plot y. And there we have it. We've got this beautiful parabola created. And the axes on the x-axis is the horizontal distance from the free throw line. And on the y-axis, this is the height above the ground. So now we're ready to see, well, what kind of model can I fit through here? And we pretty much know that with projectiles, things that are thrown, a parabola or a quadratic is a really good model to try and fit the data. Now I'm on the bottom of page 3, and it says, once you are happy with the data points, we can now use LoggerPro to obtain the model which we feel is most suitable. Now a good model is the quadratic y equals ax squared plus bx plus c, and because it's an upside down, it's a concave down or a sad face parabola, we know a is negative. So we're expecting for sure to see an a value that's negative when we ask LoggerPro to find the equation. So on here it says go to Analyze, and then it says find the curve fit, and curve fit is down here. Alright, and then you've got to choose which model you want to fit to the data, and you can see ax squared plus bx plus c. It's got capitals here. We use lowercase in class, but that's absolutely fine. And if we click ax squared plus bx plus c, and then it doesn't look like a model appears, right? But if you click on the try fit button here, now look at the line that's appeared, right? Beautiful. And over here on the right, you can see the a value is negative 0.3095. Look at the b is 1.632 and the c is 1.43. Now you guys know that the a value is going to tell us if it's concave down or concave up. The c here is the value of the y-intercept. So we've got a lot of good information. Go ahead and press OK. And now you can see on the screen you have got your quadratic model written down nicely. So what you would do is you would transfer this model now down to your book or to a Word document that you're working on, and you would write out the quadratic model. For me, the way I've traced out the ball, and it might be different for you because your data points might be slightly different. You might have clicked a slightly different place on the ball. My equation is y equals negative 0.3095 x squared plus 1.632x plus 1.43. Now the key thing is, how do we now use this model to determine whether the ball is going to go into the basket? Well, there's one more piece of information which you definitely need, and I've got that on my Word document here. If I go to the final page, here's the key thing. The horizontal distance to the basket is 4.06 meters. So when x is 4.06, the height of the basket is 3.1. Okay? So think very carefully how we're going to use that information to determine whether the ball goes into the basket. Now once you've done shot 1, you've got this data here. This is all beautiful. You would go ahead and then go File, and you would save this. Now you'd save it into whichever particular folder. I've got a nice grade 9 folder. I will save this as shot 1. I would save. I would say yes, that's okay. Brilliant. And then I would do File, a new one, and then I would do the same thing again, and I would analyze shot 2. Alright, so you would insert movie again. You would go and find the movie. I wonder if you can just drag and drop in. I'm not too sure. You could experiment with just dragging the movie and dropping it in and seeing if it would work that way. I need to go to my downloads. I'll go back to the movie again. There it is. And I will just go ahead and play this first before I do anything else fancy. And I'll stop it just at the start of the second shot. So this is the first shot again. I don't want that. There's shot 2. I'm just going to move the frames. I'm going to go forward frame by frame with the fast forward arrows, although it doesn't seem to be going that fast. Keep click, 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 click. And there he is again, getting ready for the second shot. Okay, standing up straight there, so I'm ready to go again with the calibration, the measuring. Bottom right, click to open up the toolbar. Third button down, click to set the XY axes, right, and right on the free throw line at the feet. That's pretty good. And then the one below it to measure the height of the person to get the scale going. Green arrow, perfect. The height is 1.9 meters. Perfect. Everything's ready to go now. Just click forward. Ball's going backwards when we feel beautiful. I think that's good from there, and then off we go again. Click, 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 and so on. All right. So you got 3 shots. Save them as 3 separate files. You'll get 3 separate quadratic equations, and that's the key goal. And then we'll be able to sit and discuss how we determine whether the ball actually does go into the basket. Okay, that's all for now.